push that rock here with some cement. So we have the double angles. We're going to use them to derive another set of identities called the half angles. And we're going to focus right here on these two to do that. So we have cosine of double the angle is equal to 2 cos squared of the angle minus 1, and cosine double the angle is equal to 1 minus 2 sine squared of the angle, okay? So here's the one of them. And what I'm going to do is I'm going to say, let's let theta be x over 2. Because theta is a number, right? It's a radian measure, it's the length of an arc, or you can think of it as angle measure in degrees. So, you know, if it's 30 degrees, well, there's some number over here, 60, that you cut in half to get the 30. If it's 15, well, then 30 divided by 2 is 15. So any number that you put here, there's some number you can cut in half. If you put 7.5 over here, well, then clearly 15 divided by 2 gives you 7.5. So we're going to set up this relationship, and then we're going to substitute in x over 2 for every theta. So I'm going to say cosine of 2 times x over 2 is equal to 2 times cosine squared of theta, which is x over 2, minus 1. Now here, we have that going on, and we have cosine of x is 2 cos squared of x over 2 minus 1. So now you see we have an angle being cut, and what we think of the inputs as angle measurements, so we have an angle measurement being cut in half. Now I'm just going to solve for cosine squared, so I add the 1 over. And I divide by 2. That's supposed to be an x, sorry. And we can think of this as the half angle identity. Or you could say, well, I don't want the square here. I'm going to take the square root of both sides. And if I do that, well, when you square root a square, it undoes it. And so I just have cosine. The only problem here is that whenever we take the square root of both sides in an equation, well, it introduces this nasty plus or minus situation. Like you're going to either get a plus or a minus, or maybe both, depending on the situation. But in this situation, it's going to totally depend on your angle measurement. You know, if x is, say, 120 degrees, well, then 120 divided by 2 is 60. So we're going to be in quadrant 1, and so therefore we need the plus. But if x is, 330 degrees, do I need to be that big? Let's see, or 300 degrees, and I cut that in half, then I'm at 150 degrees. Well, that's over in quadrant 2, so I would need the minus. So you have to just think, where is this, what quadrant is the angle in if you enter? So you can think of either one of these as the half angle identities. Now so this is the half angle for cosine. Let's get a half angle for sine using this situation. So again, I'm going to use my trick that I can write theta that way. That allows me to do this. Everywhere I see a theta, I put an x over 2. So now I'm going to add this over here and subtract that over there. So I'm going to add the 2 sine squared of x over 2 to the left side and move this over there. So I have 1 minus cosine of x. And then I just divide by 2. And I have another half angle, this time for sine. Or I can take the square root of both sides again and think of it this way. But I have to, have that there, and then I have to think about what quadrant I'm in to know if it's plus or minus. But I mean, that's how we always handle these anyway. So, okay. So our half angles for sine and cosine are these, or they are these. And there we have it. So let's use one of these. So let's evaluate cosine pi 8. Well, the first thing I notice is that pi 4 cut in half is pi 8. So I can rewrite pi 8 as pi 4 cut in half. And then that means the half angle identity comes into play. And remember, the half angle is cosine squared of x over 2 is equal to 1 plus cosine of just x, the whole thing, divided by 2. Or if I take the square root, I get rid of that square on this side, and then over here I introduce the square root. And it's plus or minus, but which one is it here? Well, you know, clearly pi 8 is in quadrant 1. So we don't need the, it's just positive, okay? So it's just the positive one. Okay, so I'm gonna switch to this. Now what's my x here? Well, my x is what, you know, the angle that's being cut in half, so pi 4. So pi 4 goes here. So see how we cleverly went from pi 8 that we don't know. We don't know cosine of pi 8. That's not one of our convenient angles. To cosine of pi 4, which is an angle that we're familiar with. So then what is cosine of pi 4? Well, you know, it's either 1 over root 2, or if you rationalize, it's root 2 over 2. I'm going to use this version here. So I'm going to have root 2 over 2 all over 2. Now I'm going to simplify that. So what I'm going to do is I'm going to multiply the top of this fraction by 2. Now I put that in parentheses because if I'm going to multiply the top, I have to multiply this and that. Then that means I have to multiply the bottom by 2, so I'm multiplying by 1. So what does that do for me? Well, it gives me 4 in the bottom, which that's nice because the square root of 4, we know that, that's 2. So we got rid of the square root in the denominator. Now in the numerator though, I go 2 times 1 to get 2, and then I go 2 times this to just get root 2, and then that's not going to simplify. We're still going to be under the radical because you can't take the square root of a binomial, you know, that's a problem. So that's the exact value of cosine of pi 8. And this is considered a beautiful expression. I mean, look at it for a minute. Look how we have all these nested 2's. You know, we have square root of 2 inside a square root of 2 that's added to 2, and that's all over 2. It's kind of beautiful. You know, what is that approximately? Well, golly, you know, hey, it's, you know, somewhere on the unit circle. You know, we could, if we were just approximating, if we were just going to get an approximate, we didn't need to do any of this work, you know. So there's pi 4, and we know that is, you know, 1 over root 2. So pi 8 would be something like that. We know that at here cosine is 1, so it's somewhere between, and this is approximately 0.2 over 2, so about 0.7, because square root of 2 is 1.4 over 2 is about 0.7. So it's somewhere between 1 and 0.7. So we could get an estimate based on that. So the beauty of this is it gives us an exact value. Math made simple. It's Math.